What's up, everybody? Welcome back. Today we are working on making an event-driven signaling mechanism for our Zig web server. So context is we are making this collaborative Rube Goldberg machine. So the idea is that we're going to have a bunch of chambers, and these like balls are going to move through these chambers. What happens in these chambers is defined by some user uploaded code, like in a WebAssembly module. So right now we have some examples of executing some WebAssembly modules. The chambers aren't stitched together, but the concept is like kind of there, right? And so what we want to do next is we want to create this way for people to actually upload chambers, which means that they need to have some sort of account so that we can like tie together who uploaded what and maybe punish them if they do something that's like really fucked up, right? And so we were kind of looking at this like OpenID authentication flow where we can ask Twitch to say like, hey, could you tell me who this person is? And then we can like, Twitch goes like, oh yeah, sure, no problem, here you go. And the flow there is like a little bit complex, but I think explaining the flow will give some rationale as to why we need to do this like event signaling system. Okay, so I am a server. My name is spheraphoria.dev or something. Doesn't really matter. The login flow is that some guy comes over, client, and he says like, hey, I need a web page. Could I log in, please? And we go like, sure, here you go. And here is a one-time token. He goes over here and he talks to Twitch. Maybe I'll put Twitch here. Twitch. He goes like, hey, here is that like nonce thing. Can you generate me a response? Twitch goes like, yeah, sure, no problem. Here you go. Here is a code now. Now we have a code. So we've gone from nonce from here to here, code from here to here. He gives us back the code. And we then, with that code, reach out to Twitch and say like, hey, who is this guy? Like, this guy gave me this code here. Who is this? And then Twitch sends back his like ID plus nonce. That's kind of like the authentication flow in general. And so the important part for this like event-driven system here is that when we go from like here to get to pass us the code, our server needs to reach out to Twitch and get some things from the internet before we can answer this guy, right? Which means that like we have a problem because all of our connections are kind of modeled as like one thread. So we have this like event loop thing going on, and he like kind of sits over here, and he's kind of based off this like epoll mechanism. So the idea is that like we spawn like a TCP listener, TCP server, and he's attached to like one file descriptor, right? So this is like, you know, file descriptor 4. When people connect, we go, hey, so I saw some traffic on 4. Let's like call into this thing and do some work. And this guy will be like, okay, so now we have connection. You know, we have a new connection, and this has file descriptor 5. And what happens is we might accumulate like lots of these connections, right? And basically we don't spin up new threads for all of them. It's just when we have work to do, we do them, right? So the epoll system in Linux will say like, hey, somebody sent us some data on 5. Can we call into this? And someone sent us some data on 6. Can we call into this? And the important thing to realize here is that if we were to like call into this, and this took like 5 seconds, nothing else would be able to happen for 5 seconds, right? Which means that if our system says, hey, the client sent us this code, and we need to send him a response, and we have to reach out to Twitch to generate that response, then like our whole event loop stalls until Twitch gives us an answer, which is bad, right? But the other problem here is that we only get woken up when there's like new traffic, right? So the client sends us the code, and the event loop goes like, hey, we got some like input on file descriptor 5. Do some work, please. And so if we were to then say like, okay, now go back to sleep while we like go try to like talk to Twitch, we would have no mechanism to wake us back up. And so that's what we need to look at today is like, we want to send this guy back to sleep so that we can service other traffic and then have some way to wake him back up when we've done whatever work we need to do. And so I believe the right answer to this equation is there's this thing in Linux called like event fd, right? And this thing basically just says, I have like, I think, I'll have to double check this when we get a little bit into the details, but I think it's like I have like a pair of file descriptors. Maybe it's one file descriptor. But like if you were to call read on this end, you know, read, it would do nothing until somebody writes this end. And that's all it does. It just wakes up the other side when you have something to do, right? And so what you could do is we could connect this connection to like some event file descriptor as well, right? Now all of a sudden our problem is solved. We can go do our work over there, and then when we're done, we just write to this thing, and epoll will be like, oh, well, yeah, we need to wake up. We need to talk to this guy. Great. Everything's hunky-dory there. Now, the problem is when we spun up this TCP server, right, he's spawning all of these connections and giving them to the event loop. And what's important to think about here is right now, the exit condition of these guys is basically like either we give our answer and we're like, okay, we don't need to work with this guy anymore, we'll shut him down, or the other end closes the connection, right? So like my client here is just like, hey, could I log in? And then he's just like, fuck it, never mind, I closed my browser, go away. And now all of a sudden we go like, oh, there's no data to write here, so we'll kill this, we don't need this anymore. Now if we were to connect this to two pieces, now all of a sudden our existing flow breaks, because now say that like the TCP connection closes, we delete this guy, but then our event system is like calling back into this and we're going to be working with invalid memory, right? So the first thing that we have to do is make sure that our HTTP connections are like reference counted, so that when these guys destruct, like delete themselves, we only actually delete it when everybody's done with it. That's step one. Step two is we need to basically like make these guys support waiting in some way, right? So right now we say, hey, I read some data. Now, what do I write? Okay, I'll write that now. We need to have some sort of like intermediate state that's like, okay, somebody else is going to tell me what I can write and when. And then I think that's basically it, right? But I think that this will end up being like a fair amount of work. And so I think it gets its own stream. Oh yeah, that's the plan for today. That's the plan. And I think we can just kind of like jump right in. I think reference counting is the easier place to start, so I want to do that first. What's kind of nice here is because our event loop isn't really thread pooled or anything right now, we can actually probably get away with no atomic reference counting, right? So usually if you had like, 4 threads accessing this thing, you would say like, you know what, like when, how do I say this? When I free this guy, I need to make sure that all other threads know that I freed him, and I need to stay consistent with all other threads. But if we're doing everything on one thread, maybe it's okay. Let me think about this for a second. I changed my mind. Because I think that what's going to end up happening is like one way to implement the side like talks to Twitch and gets the data is we could make like in our event loop, we could make like an asynchronous HTTP client, right? And we could have him talk to Twitch, and then he would run the event loop and come back. I don't want to do that right now. So I think what I'm going to do instead is I'm going to have like event loop thread, and then I'm going to have like HTTP client thread. And I think we are going to, from this guy, write directly to our HTTP connection. I think. In which case we do need atomic reference counting. Maybe we'll start with atomic reference counting now, and we can always back it out into like the simpler version if we find out that we don't need it. But I think that we actually will. Which means that here we're gonna have some sort of like ref count. And he's going to be some sort of atomic value. Sure. So this is gonna be atomic int I32, U32, U8. How many people do we think should hold on to this guy? Surely we won't have more than 255 references to him. I actually expect that we're gonna have 2. So I think a U8 is totally fine here. Then when we initialize this guy, our ref count is going to have to be something. I don't know how to like initialize this guy. So can I jump to definition on this? Yep. Init with value. So I'm just gonna init with him with 1. So it's atomic U8 init 1. And maybe we'll make a const ref count is equal to atomic U8, because that way I don't have to write atomic U8, and if we decide to change the type later, it's easier to fix. There we go. Here we get ref count, boom. And okay, so we have 1. On dinit, we basically say, I'm gonna take my reference count, and surely they have some sort of like fetch sub. Okay, what does this do? I'm assuming that like we have to be careful, right? We need to make sure that like thread A decrements ref count, thread B decrements ref count. One of these guys has to see 0, because when this reference count gets to 0, that's when we're actually going to free the memory. And so I'm not really 100% sure if this fetch sub, like everybody will. I'm not sure if like two people will end up seeing the 0, right? If they trigger at the exact same time, you could go maybe like two, both decrement atomically, and so like both decrements get applied, but do both see the 0? That's what I'm not sure about. So I need to look that up. Fetch sub. This is not what I want. I want, oh, this is probably fine. It probably follows the same semantics as C++. Performs atomic post decrement. This operation is read modify write. Memory is affected this file, blah, blah, blah. The result may be an undefined address. Okay, the signed integral types arithmetic is to complement, blah, blah, blah. This doesn't seem clear to me. This is a read modify write. So is this the same as doing like a compare exchange? Not sure. Let's look at the Zig docs as well. Maybe that will help us. Fetch sub Zig standard loop. Let's see what it says. We want this version and atomic. We just want to look up like, what was it? Fetch sub. It doesn't have any docs on it, which kind of makes sense. I think that these are like supposed to be well known. Okay, well, since I'm not positive, I know that if we do compare exchange, we will basically just reject the thing until we know that like two people weren't acting on it at once. So I think I'm just going to do that, even though fetch sub might be fine. I'm just not 100% sure, and I am 100% sure about compare exchange. So I'm going to do it that way. So if I remember correctly, weak and strong are basically one of them you just do it in a loop, and one of them you don't. I think strong is no loop. So our expected counts, we're gonna like, I guess we're gonna say while true, we are going to like extract the current value of the ref count with atomic stood atomic ordering. No, where does the ordering come from? Atomic order. What is atomic order here? This comes from built-in. I see. Stood built-in atomic order. Unordered. We don't really care about the ordering with everyone else. We just need to make sure that we get like something. And then here we'll say val. Let's do this. And then we do a self ref count. Compare exchange weak. And what does this give us? Compare exchange weak, compare exchange strong. So I guess we could, I'm assuming that compare exchange strong will give us the return value is the value if it changed, I would guess. This is using comp exchange strong built-in, so we could probably look at the built-in docs. Compare exchange. Function performs a strong atomic compare exchange operation, returning null if the current value is not the given expected value. Returning null if the current value is not the expected value. I see. So if old value is, it's the equivalent of this code except atomic. If the old value is equal to the expected value, we set the new value and return null. Otherwise, we return the old value. So null means success, which is what I would have thought. Returning null, no. This doesn't look right to me. This I think disagrees with this. Right here, he extracts the value from the pointer and he says, if this is expected, then we like do the store and return null, otherwise return the old thing. Where old value is what we read right now. Yeah, so we should, yeah, okay, I think I understand. And then weak is the same thing, but if you're using comp exchange in a retry loop, the sporadic failure will be no problem, and weak is a better choice, which we are doing. Because it can be implemented more efficiently in machine instructions. However, you need a stronger guarantee, use strong. So we're using weak. Yeah, and this is like, and usually true, but sometimes false. Yeah, this is exactly it. So they say sometimes we will wake up for whatever reason. Maybe like a signal was fired and we broke out of our inner loop or something. Okay. So here we load the value. I guess we load it once here. And then we say const ret is equal to this. And we are compare exchange weaking with the expected value, val. That's what we got. We're trying to go from val to val -1. Simple. We're trying to decrement it by 1. Success order is, I think both of these, we don't really care about the memory ordering. So if I remember correctly, this ordering is like, how is the memory around us affected, right? So if we are saying that we expect that, like, I make a change in one thread, and then I wait for this atomic value to get set, and then I work with that memory in the other thread, now I need to make sure that, like, that memory, like, these instructions didn't get reordered around each other and stuff, right? But since the only thing we care about is the value itself, because only one of these threads is going to do an operation on this thing, then we can just say unordered, we don't give a shit. And say if ret is null, I guess if ret is not equal to null, val is equal to ret. If ret, yeah, we'll do this. Val is equal to ret, and we continue. Else we break. Boom. Yeah, that sounds right. And then here we should know. Well, here we have to say val is equal to val minus 1 as well, so that at the end we know what our count is. Yes? Does that make sense? So this is like, it's not what we expected, so we got something else. We reassign, we continue. Otherwise, we did, the decrement succeeded. So we can say like new val here to make it more clear. So if we succeeded, we are the new val. There we go. Then here we can say if val is not equal to 0, we return. Right? There's nothing to do. Unordered is enough, don't need any space. That's a really good point. Good point, thank you. I usually do it that way. I just don't know why this time I didn't feel like it didn't trigger that path in my brain. Okay, so here this should ensure that only one person does the dinit. I'm not like 100% sure, but it feels right. Feels right. Which means that now we should be able to. How can we test this? I guess we can. I guess we need a way to increment the reference count as well. So I think that what we'll do is I'll make a function ref, which takes the HTTP connection and returns a new HTTP connection. And this just returns self, but maybe it returns a pointer. So all of them point to the same memory location. That seems right. And we just say self ref count plus fetch add. So in this case, we're not looking at the value after. We just want to make sure that it gets incremented by 1. So I think that this, I don't need to worry about the like, what the fuck? Operand t. This is a type. So I guess, what the fuck? What is this t? I don't understand. I would have thought that I just typed 1 here. Oh, this is, I'm an idiot. T is the number. Got it. So at fetch add 1. And with unordered. And then does this this applies to the thing in line, right? Like this returns a new thing, but I don't think I care about that. I think. We'll see. We'll see. And then we return self. So this should say, hey, we are taking a new an extra pointer to this thing. So like when now the existing guy, when you did it, don't worry about it. We will do it later. And so I should be able to do something like spawn one of these guys, like maybe hand them off to like 1,000 threads and dinit it. And then we should make sure that we get one dinit at the right time. I think that's the best way to check this. Because like multi-thread code's like kind of hard to test. But yeah, it's fine, it's fine. Okay. So let's, maybe, for now, we'll just shove a little main. We'll make a new file. We'll make a new file. Fine. Fine. We'll call this, HTTP test zig. Pub function main. We need to import, HTTP zig. And we need to try to make a connection. So const var connection is equal to HTTP connection. initialized with some allocator. So const alloc is our GPA, var GPA is equal to stud. So we need const stud, import stud. Yep. This is stud heap, general purpose allocator. I don't give a fuck. Defer GPA d init. Const alloc is equal to GPA allocator. Boom. Now we can pass this in here. We need a TCP stream to pass in. So I guess for now we will just open a TCP connection to like Google or something. So this is going to be like stud net address TCP stream. I'm here. Yeah, perfect. I was worried we didn't have you. How would we have lived? I think it's init IP4 is what I'm looking for. So I guess we'll just connect to like localhost or something. Fuck it. So we can do like 127.0.0.1, and surely somebody will be listening on 8,000. Or I think I have a web server running right now on 8888. Actually, let's try that. Then we can init this connection with stud net TCP connect to address. Addy const connection is equal to this thing probably tried. Then here, is this a stream? This is a stream, so we can just pass this in directly. And what was the other thing we had here? Response generator. So we need to make one of these things. So this is to like, when we run our HTTP connection. Oh, this is a server-side thing, huh? This is a server. This is supposed to be, our server is like creating HTTP connections from a listener. Okay, wait, I think I have an example of this somewhere. We have this like interface that we implement to create a server. So I'm just gonna like yoink this, slap it over here. And he has like this, like, you spawn like a TCP server, and we basically like in this interface, like generate the rules for our HTTP connections. I don't want to do that either. I think we can do it without the event loop. If we say like stud net server. Let's think about that. That sounds right. So create a server, and oh, I think you need to addy listen. Here we go. Yes. So const server is equal to this, and this is going to be on 8,000. Now when someone connects to us, so we're going to say server accept one. Yes. We're going to get some connection, and then we are going to create an HTTP connection based off that connection. Perfect. That's what makes sense. And we still need our generator. So what is that thing? That thing is this. So we'll just copy paste this, and we'll say, I guess for now we can just write unimplemented. I think this won't cause a problem, because I think this will never get called as long as we don't issue an HTTP request. If we just open the socket and sit there, it'll be fine. Yep. Okay, so then we can just sorry, this is a let's do this. Const generator is equal to HTTP response generator with data is equal to null, and generate function is equal to this. And this, it takes in a any opaque user data. There we go. So this should at least give us the interface so that we can like create this thing. Yeah. Generator. Okay. Does this thing need to be tried? Yes. And now what we want to do is we want to say like let's start with single thread. For 0 to 100, we will write, I don't know. I guess we will like connection ref. And let's like put these all somewhere. So we'll have like connections, plural, is equal to, is like 100 HTTP connection pointers. And here we can just initialize them all. Yep. And then what we should do is we can just rip through all of our connections. Yeah. Connections. Connection. We'll do this. Con.dinit. And then connection.dinit here. Now we should. Fuck. We have so many. We've got the word connection like 4 times here. So we'll call this TCP connection. And that makes this work. So what we should see here is that we should see 100 dinits that do nothing and 1 that does something. So maybe what we'll do is we'll just like log the value here. Not de-initting. And we'll log the value that we got. And then here, we'll log de-init time now. And so what we should see is that we should see a lot of not de-initting followed by 1 de-init. The de-init has to come last. Has to come last. Which is going to happen this time, but when we get into more threads, we need to make sure that that's still the case. Still the case. Okay, zig run source HTTP test. He doesn't like that this is not defined, so this comes from HTTP dot. This comes from HTTP dot. This also comes from HTTP dot. He doesn't like that at 22 this thing is not variable, which is fair. This needs tcpcon dot stream, I guess. I thought that it wasn't, but I guess it is. Atomic ordering must not be unordered. Oh, interesting. Why? I must not understand. Fetch add. Why? I thought it was fine. I thought it was fine to be unordered if the only thing you're accessing is the atomic itself. This is atomic RMW here. Dereferences a pointer T and actually atomically modifies the value and returns the previous value. Don't you need relaxed? I think unordered is the same as relaxed. I think unordered is the zig word for relaxed. T must be a pointer. Atomic order can be found with import this. Atomic RMW op can be found with this. Okay. And it doesn't really explain why. So maybe we can look at fetch add atomic CPP. Maybe it's surely going to follow the same rules here. So here they can do fetch add with relaxed, which is my mental model. So is it possible that I misunderstood what the orderings are? If I like go to here, unordered, monotonic, acquire, release. What the fuck is monotonic? Atomic order monotonic. What is ordering monatomic? Here we go. Somebody tell me. Follows LVM atomic instructions. In C++ would be order relaxed. Wait, then what is unordered? Am I wrong about using unordered? Unordered is the lowest level of autonomicity. It guarantees that the races produce somewhat sane values in results instead of having undefined behavior. It also guarantees the operation to be lock-free, so it does not depend on the data being part of a special atomic structure. Monotonic is the weakest level that can be used in synchronization primitives. Although it does not provide any general synchronization, it essentially guarantees that if you take all the operations affecting a specific address, a consistent ordering exists. So maybe I shouldn't be using unordered anywhere. Races produce somewhat sane results instead of having undefined behavior. Synchronization primitive. So it does seem like I'm just going to change our unordered to monotonic. This is new to me. I thought that relaxed was the same as unordered, but I guess I am wrong. 295. This needs to be variable. Okay, now nothing is happening, which is a little concerning. Oh, because I need to tell them that in. Nix shell inet tills. I need to make a connection to make a connection. You know? You know? If you make a connection, you make a connection. Let's maybe in our thing put new lines. Fuck me. Oh, I hate that shit. So when things crash, I guess if I don't like properly close the server, then it gets angry. But we can just say reuse port true, reuse address true to hide our deficiencies. But in reality, we should also do defer TCP con stream. Oh, this gets closed automatically. It's this one that doesn't. Defer server close. Stream close. There we go. Server DNet maybe. One day you might download inet utils globally. Maybe. One day, maybe. Can I? Fine. We'll just change the port now for now. But okay. So this looks like it's working as intended, right? We have 100 times not deinitting followed by one deinit. Now, where this gets interesting is if we were to spawn a thread on this, and we were to say, let's make a bunch of threads that wait until some timestamp, and then all try to deinit at the same time. It would be nice to try to get those deinits as close to each other as possible, so that they all happen at like exactly one time. So I wonder what the mechanism is there. We could do like deinit, just like deinit thread or something, right? And maybe he's going to wait. Maybe he will take a like connection as well as a like shutdown. View this. And we can say while shutdown load with monotonic is false. So while this is not true, we just kind of do nothing. We'll just literally hot loop. I don't give a fuck. Then we will do defer con deinit. This actually has to be a pointer. And then we can just spawn a thread for each of these guys. So we could say std thread spawn. I don't really give a fuck about the configuration. I have a function which is deinit thread, and args are our connection ref, as well as a shutdown flag, which has to be specified. So this is going to be like var shutdown is a std atomic value bool initialized with false. And then after all of these guys are spawned, we'll like std time sleep. So first we'll like deinit our source connection so that they are all racing each other. Nice. And then we will like sleep for, some time just to make sure that they like get up and running. So maybe like 20 milliseconds just to make sure that the threads are all in their hot loops. And then we will just, say shutdown store true. Does this return anything that I have to ignore? Nope. And then we will std time sleep for 1 second again, just to make sure that we give everybody time to shut down before we kill ourselves. Okay. Fuck. Error union is ignored, so here we will, I think we also have to detach these guys. So I think it's like, try this, then detach it. Oops, and then I don't want this anymore. Yeah, something like that. Too many 000. Nanoseconds, microseconds, milliseconds, seconds. No, that's right. Nanoseconds to seconds is billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I'm pretty sure that's right. Pretty sure that's right. Detach was spelt wrong. It's a hard life. All right. And store expected 2, arguments found 1, because I tried to write dot monotonic, but I wrote dot monotonic instead of the comma. So here I need to tell that in. And this is pretty fucking clearly bugged. Oh, wait, maybe not. If the standard out buffer doesn't work the way I think it does. This could be like a locking problem. How can I check that? I mean, we do see that only one person DNITs it, but it's a little concerning that the other guys haven't necessarily, like, the ordering here is really fucked up. So how do I want to confirm this? Bump, 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 bump. Can we, like, do unlocked? Can we just, like, not lock it? Let me think. Print the timestamp when DNAing and sort, but the timestamps I think aren't guaranteed to be like correct per thread. I think that they're not, like, they could be slightly off from each other, because I think that each thread has its own monotonic clock or something. Maybe I just have to trust that it's right. Right? Because surely we can't, like, we know that it's impossible for 94 to come before 0. We know that that's true. So maybe we can just trust that since we see only one dinit time now, that does indicate that only one made it through. And I think that we can just trust that it's fine. Which is a little non-ideal, but good enough for me for now. Good enough for me for now. Maybe we'll do something like... it's fine. It's good enough. Good enough. Okay. So now we should have the ability to kind of like register these HTTP connections on our event loop with more than one file descriptor attached to them, which is a big win for us. And I think the next step, could you lock stood out before calling dinit? I don't know if that's what I want. Because then all of these guys would, like, lock themselves when they're trying to write, and it wouldn't really, like, show us, like, the ordering correctly. I think it's fine. It's fine. I'm not worried about it. Okay, sorry. So now we have the ability to register these things on the event loop for multiple file descriptors, which is big. That's big for us. And so I think the next thing to do is probably try to abuse that in some way. So we need some way for us to get into, like, a waiting state on this HTTP connection, right? So he's going to read some stuff. He's going to be like, hey, this is the request, and I want to do something now. And then we're going to be like, hold on, bro. Wait a minute. I'll tell you when I'm ready. Which means that he needs to, in that state, go into, like, some wait state. And I don't really know how that's going to look yet, but I kind of feel like if we just start implementing, it'll become pretty clear where this stuff belongs. So if we're in the wait state, when the event loop talks to us, we want to basically try to, like, unlock ourselves from that wait state, I guess. And I guess since this, like, HTTP connection is generic, in that, like, the way it works is when we generate this HTTP connection, we talk to this, like, response generator, and this response generator is responsible for telling us what we should write back out to the HTTP connection. So we could probably do something like, if we're in the wait state, we should ask the response generator if he's ready. So we could maybe call, like, generate again. And right now, this is kind of how we've been doing it. Is like our writer thing gets like set by this, and then our self state gets put into write. And what we should do now is like, I guess this generate function could tell us, like, could return a writer, but it could also return like nothing. And if it returns nothing, then it will be like, we can say that we are not ready. That seems kind of reasonable to me. Right, so here we can say we are not ready, and then we are gonna have some compile errors where everybody who's currently registered as an HTTP writer won't return the right thing. So this is in user info zig. We have a server that I was playing with yesterday off stream. But we just have to kind of do the same thing here where we go, boom, throw some question marks here and here. And I assume that there's one in main for our normal server as well. So here, oh, it's in server maybe? Yeah, here it is. So it's our generator. This guy needs to return a question mark here. And we also need one here. Yes. We are not quite there yet. It's still fucking busted. So expected type that shit show got this shit show instead. Probably we just need to write try on there to like do the coercion. So 354 in user info, I think it was 354. This needs to just be return try. I think that fixed one of them. Oopsies. What did I just do? We have one at HTTP 338. So here, now, right, the users of this guy, they basically need to say, like, hey, if this thing returns null, we will set our state to wait. Otherwise, we set the state to write, which seems fine to me. And then there is at 390. Right, this needs to pass in our reader so that it like the reader kind of holds the state of like, well, what did this guy ask for? And so the writer, like when we generate the response, we need to know what was asked for, if that makes sense. And then this guy needs the same thing applied. So it's try this or else self state is, oh, I guess we just write continue here. Right, nothing changes if it's not ready. I guess we need to return in this case, actually. That seems reasonable to me. And that kind of indicates to me that when we're in like the read state, like if we go into this read, if we're in this read state and we try to set up a response here, we are going to kind of call this situation twice because we're kind of like in a loop where we like try to do everything that we can at once. So maybe here, instead of going into setup response here, we just call self state is equal to wait. And then this setup response actually is exactly what we needed. So here we should change this to self setup response. This. Yeah. And then if we get into the deinit state, we'll deinit, so we're chilling. Yeah, I think we're fine. That feels right to me. Do we compile? We do compile. And so I guess maybe we should make like a little dummy HTTP server here that actually does something. So let's start by let's make a shitty little server, and we'll just kind of copy paste this shitty little server. So we need a const allocator stud mem allocator. And here we'll just we'll make a body that says like hello world. We need a TCP server, so const TCP server is equal to import TCP server.zig. Okay. We need an event loop. Now we can just kind of spawn that HTTP server. So we can go back into this example and just kind of like slurp up all this. like this. Where's our event loop? Event loop here. Okay, so we make an event loop, we construct a TCP server, we attach that TCP server to our spawner, which will generate our HTTP connections, and our HTTP connections should return this hello world index if everything in here was copy pasted correctly. So if I go into localhost 8000, we do see a hello world, so we've got like a server that handles HTTP connections. Now, what we want to do is in our spawner, in our generate response, instead of returning this, what if we return null? Right, so we're like not fucking ready yet. And here we'll be like deferring. And we'll say this goes self. Now, when we run this thing, we just get spam pulled on deferring, which is interesting. And this connection is just never, this like page is never getting loaded. So I don't like the fact that we are spamming deferring. I don't like that at all. I would think that it should just wait. So what the fuck is going on there? We need to return in this case. We need to return in this case. So maybe this will return a Boolean if we succeeded. And in moving states, and then we'll say if this did not succeed, we are not ready, return none. No action to do from the parent, but we need to get out of this fucking loop. So now when I refresh, we get one log of deferring, and this connection will never resolve. Wonderful. Wonderful. Okay, what's the next step here? The next step, I guess we kind of are in the wait state now, and we need to get out of the wait state. So somebody has to register this HTTP connection with the ePOL system. And I guess that's kind of the responsibility of our thing here. So I guess he gets like a reader, but maybe here when we call generate response, we actually just give him the whole fucking HTTP connection. And this guy has a handler function. So we could like maybe we just give him a handler. This is going to be an event loop event handler. So the idea here would be that we are capable of giving this handler off to the event loop with some file descriptor of our own. But that wouldn't increment the reference count. So I changed my mind. Let's go back to the idea of giving it the whole connection. Okay, so that's going to break all sorts of shit. So we can just kind of start by fixing those compile errors. No? Why the fuck not? Whoa, 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 what the fuck? Am I high? Oh, because this isn't part of the build system. Fuck, that's why. This file is not part of the build. So that's why I've successfully compiled still. Okay, we'll change the interface. So on HTTP, our generation function now takes in a HTTP connection, and this will break everything. Okay, so this goes like this. We've has a connection like this. Now everybody's gonna get mad. Perfect. Okay. So this needs to pass in self instead of self-reader. Who else is mad? Server.zig 158. So this guy needs to take in a connection. This takes in a star HTTP connection. This can pass in, I guess, connection.reader for now. Seems reasonable. And we'll probably give the same treatment to the one in user info. where he needs to take in a connection, HTTP connection with a star on it, and we pass this on to the child to keep the way it was. Everyone happy? Everyone happy. Okay. So our HTTP test, though, the thing we're actually working on, is not happy yet, so we need to fix this. So this guy needs the same treatment. Uh-huh. Okay. Everyone happy? Everyone is happy. Okay. So this guy needs to do something. He needs to like clone this connection, right? So we're certainly going to do like new connection is con ref, right? This we need to increment the reference count, and we need to maybe our server keeps a reference to the event loop, right? So when we construct this guy, we'll just say that event loop is equal to event loop. And now in this context, we could do something like event self event loop register, and we can just register this like new connection, right, with this in some way. So this would have to do like an error defer new con d in it, which probably means that this has to be variable. Here we need to try to register something. I'm just gonna put the number 0 there for now, which is like just super fucking wrong. But that's okay. And let's think about this. We say like new con handler here. Now, what's a little concerning here is that this generate response is being called every time that we want to check if there's something ready. And so what's going to happen here is that we're kind of like we will register like 400 times, right? If this like gets pulled over and over and over again, we're just going to keep registering new handlers, which is bad. That is bad. So what can we do there instead? We need to like know if this particular connection, we need to know if like this connection has already registered itself. So right now we've kind of attached everything to like the server itself. So this is like one instance for all connections. We could like give it something that's like one instance per connection. That's probably doable. So that's gonna happen is when we call our spawn function, we create a new HTTP connection with this response generator. But I wonder if like this response generator could be tied to the connection in some way, shape, or form. I think it could be. So we could like maybe on here. Let me think about this. Sorry, the memory model here is kind of tricky. It's kind of tricky. So we have like TCP server, and then we have like, he's got like a spawn handle, and this guy like spawns HTTP connections that are tied to like this like server instance over here. So this is kind of like connected like this. And then for each connection, we call into this thing, and it generates a new, like, we have a lot of HTTP connections. And each of these gets the output of the thing generated with the spawn handle. This is like a new thing. Now, right now, we're kind of tying this back to like the server, but we could like allocate this and like stick it just like in the heap somewhere, and we could like connect it to here. And we could say that like when the HTTP connection is freed, he'll free this guy. And that way we could have like state that's tied to this particular connection while still having this connection be totally generic. And so with this, the only problem is that this is like an interface. And in like Zig CLAN, the interface has to get tied to like some concrete instance. So what we actually want to do here is like, this will just be kind of like on the heap somewhere. Data. Ew, this is gross. But I guess this is what you get when you do like generic programming is you get this like web of bullshit, which I usually try to avoid, but in this case it felt like it made sense. So we'll kind of like shove this shit on the heap and then make it so that this guy has like a dinit function. And so when the HTTP connection is like out of data, it'll like call this dinit, which will dinit this. Fuck, that's gross, but it is what it is. Okay, so connection data. And so he's going to have like something. I don't know. Event FD. Right, so the idea here is that this is going to be some sort of flag for if we've already registered ourselves with the ePOL system again. Oh, it's so fuzzy in my head, man. It's so fucking fuzzy. So then, when we create our response generator, I'm pretty sure that this guy has to have a dinit function on him. So this is just going to be some sort of like function that takes in our user data and returns void. And this is going to take in our this HTTP response generator. And he's just going to call. This is like, I guess not everybody will provide a dinit function. So we're going to say like if self dinit function f. I think that makes sense. Maybe. I don't fucking know, man. And then when we dinit this guy, we call self dot response generator dinit. Okay. So that's everything that needs to get hooked up there. And now all we have to do is when we make this guy say dinit function is equal to null, just to like keep current behavior everywhere. So here we have to fix all of these guys. They need to add null. Oh, so first of all, we need to pass in the user data. Of course. Okay, and then server zig 156 needs to pass a dinit function, which is null. He's got nothing to worry about. And then user info has the same shit. Okay. Now in our case, we actually do want to do something. So when we create this thing, we are going to wrong window. Where were we? We were in HTTP test. So when we create our new response generator, we're actually going to create a new one of these. Okay. So maybe this is like something that can error out as a connection data. Maybe this can't fail because he's just going to return event fd is equal to null. And he is actually going to return a pointer to himself. He's going to keep an allocator so that he knows how to dinit himself later. Yes, which means that this can fail, and he's going to take an allocator here. Okay, it's coming together. I kind of like this. I don't really have a full picture of everything, but it's good enough shit. This is kind of fun. So here, in following the API, I guess we need to have a, return value is equal to try alloc, or create connection data. And then ret is equal to this. And then we return ret. And then down here we have some dinit function, which takes in a connection data. Sure. And he just frees himself. Boom. Okay, so that's this part ready to go. And I guess when we create our response generator, we're going to make one of these things. We're going to say connection data is equal to self. Connection data init with our allocator, which means that this can fail. Which means that here we're gonna have to say const generator is equal to try self response generator. Then here we pass in the generator. And this kind of indicates that if this fails, we should free this guy. Sure. That seems fine. I think that this is not a public function, so we need to make it public. So that this will work. And, okay. So here, if something fails, which I don't know if it will, but we should write this just to be sure. Self alloc destroy. Or I guess it's just connection data dnit, boom. We need a dnit function here. So our dnit function that we are giving to the interface is something that takes in our user data and returns void. And our user data, I guess, is the connection data. So this turns into connection data. And we just return self.dnit. Okay. Sure. And then this data pointer, I guess, has to be this connection data. Boom. Okay, that all kind of comes together. I think dnit means self pointer. Yeah, you're right. You're right. Okay, so that kind of feels like it all works. I don't really know, but we'll see. We'll see how it falls over. Maybe we'll segfault somewhere, maybe we won't. And now we can when we come into this like generate response thing. Oh, this now is also wrong. This generate response thing needs to take in a connection data. Yeah. And that means that the generate response needs to live on connection data, not on our server, which makes a lot of sense because we're trying to do something that's local to the connection. Okay. And so now in here we can say if our event fd is not set, we have to register with event loop some file descriptor. Yeah. Otherwise, then I guess we have to check if we are ready. So maybe in how do we want to test this, right? So we're basically trying to say, hey, we want to stall this connection until hand wavy something happens, right? But we haven't really like determined what that something is yet. Let's maybe just like wait for a standard input event, or to prove the concept, we could wait till another button on the web UI is pressed. That sounds like too complex though. Let's build up to that. So the first thing that let's do is we'll maybe give this guy a reference to an atomic bool. So we'll just be like enter pressed is a stood atomic value bool. And if the button is pressed, then we can generate an HTTP response. So here we'll just say if self enter pressed load is true. For now, we will just stood debug print enter was pressed. And instead of actually generating anything right now, we're just going to stood panic YOLO. Okay. Now, I guess we also need in this connection data a reference to the event loop. But maybe instead what we'll do is we'll take a reference to like the server. And the server can kind of own all of like the common stuff. So here he's going to live over here. And so this can be self-server enter pressed. Yes. Okay. It's coming together. And then over here, maybe we will just like, we need to create a enter pressed thing. Yeah. So here we say, enter pressed is a stood atomic value bool. initialize the false. We spawn a thread. And we just say, this is going to be like, wait for enter. And he's going to take in enter pressed as a argument. And we just say like, fuck off. We'll just like forget about this thread because we're in debug mode. And by debug mode, I mean like we are debugging and prototyping, not that we are compiling in debug mode, although we are also compiling in debug mode. It's just unrelated. Here we'll make a like wait function, wait for enter. He's going to take in a pressed is a stood atomic value bool. Yes, yes. And we just need to do like stood IO standard in read. Sure. Buff. So we need to read into a buffer. So it's just like var buff is like a 1U8. Sure. And then we read into buff. And then here, it's not actually, we'll just like, it's like literally any key press that we will accept, which is fine. And then we can just say press store true. Maybe. I don't know. That seems like it might set a value when it's ready. When like I press a button on the keyboard. Maybe. I don't fucking know. I don't know, okay? I don't know. We'll just see what happens. Okay, so following the broken code, here we say enter press is equal to enter pressed. And then I think over here somewhere we create like a connection data that needs that enter press passed in, surely? No, he just gets a server. So he needs a server passed in, surely, though. Don't call me Shirley. Never funny. Never will be funny, but I'm going to say it over and over again anyways. Okay. Yeah, so then this guy needs to pass in self. Boom. And I actually don't want a zig build. I want a zig run this thing. So he's mad about some like pointless discards. Some pointless discards here, I see. And then event loop found event loop at 134. So this needs a little ampersand. Value of usize ignored, so 115. This is ignore the response, even though I shouldn't. I don't really care. No event loop and connection data at 44. So this is self server event loop now. Okay. Okay. So now the last piece here is that we need to register. In this case, we need to create an event file descriptor that we register with our event loop. So this is like stood POSIX event file descriptor. Thank God this exists, by the way, because I didn't actually check, and that would have sucked if we had like if it wasn't like implemented in Zig. So how the fuck does this thing work? How the fuck does this thing work? I'd like just know that there's like a file descriptor that you can use for events, but I've never actually like looked. Or I have, but like not recently enough that I remember it. I guess I should say like not in the past like month. I haven't looked. So here we construct an event FD with 0, 0. What does 0, 0 mean? Initial value and flags. So this can be used as an event wait notify mechanism by user space applications and the kernel to notify user space applications of event. The object contains an unsigned 64-bit integer counter. The counter is initialized with the value specified in the argument init val. And what are the flags? I don't care about these, probably. Yeah, I think 0 is fine. Non-block is like kind of interesting, but because like the only reader of this thing is going to be epoll, then it doesn't actually fucking matter. Because we don't actually care about the value in there. We just care that we just care if it like gets triggered in some way, right? So we can just say that this is 0, 0 is fine. And we'll say self event FD is equal to this. And then we just need to register this thing with the event loop, which is something like this, I guess. Right, so we create a new HTTP connection reference, and then we register self event FD with that new reference. We probably have to, if this fails, we kind of want to close this event, I guess. Stood POSIX close. And I guess we also want to set this to null. So, because like we are not registered if this fails. This has to go the other way. I guess it makes sense to probably maybe do this as one block so we can think forwards instead of backwards. Like this. Uh-huh. And then here we just kind of say we're not ready. So here we'll say, here we'll write we're deferring, and here we'll write registering event FD. Okay, okay. Sure. Yeah, why not? It's kind of funny that like usually when I'm writing code, I feel like I understand like the full picture. But here I'm like, I don't really feel like I understand the full picture, but just by following the process, I'm not really convinced that it's wrong either, right? I'm just kind of like following where the things go wrong. I'm like, I think that all of this works together correctly. It's just like I don't have the full picture in my head. But you know, we are going to bite our tongues in a second when it fucking segfaults, and I don't understand why. Okay, so here I should be able to telnet in 8,000. What am I missing? What was happening here before? So we spawn a thing on 8,000 and we wait for, oh, this is an HTTP server. So we have to navigate to this in the browser. That's right, that's right. No telnet involved. No telnet involved. So we here refresh, we get stalled, and here he says he registered the event failed descriptor once, but he's deferring a bunch of times. Now, what I was hoping is that when I pressed enter, we would see the event trigger. But of course it doesn't trigger because we need to, like the Boolean gets set, but we need to write to that file descriptor somewhere. Of course, of course. So maybe everybody can be related to the same file descriptor. Let me think about this. No, that doesn't work. Because the ePOL system, he basically has like a one-to-one mapping of file descriptor to... We have a one-to-one mapping of file descriptor to callback, right? So our callback has to have a unique file descriptor. And so somewhere we just need to write down all of the file descriptors that we currently have outstanding. So here we want to do something like when enter is pressed here, we need to write to some file descriptor. Or write to many file descriptors. Everybody who's currently waiting on us, we have to tell them. So this is going to be like some pointer to an array list, I guess, of I32s, right? So somebody, like, we're going to grow this list as new connections come in. And we'll just write them all. So then we can just go for event. This should be mutex protected. Okay, we'll say const event fd list. This feels right to me. This feels right to me. This will own this list. Yeah, and then I guess we will just kind of say we also have a mutex. Mutex? Where's mutex in this? Stood thread mutex? There it is, yeah. And here we'll just kind of write signal, or yeah, signal. And we'll also, here we'll just say, we rip through the list. For FD, self FD's items. We say, POSIX, write FD, boom. I guess we have to write something to it, so we'll just kind of write like a, you know, the number 1, I guess. Like, fuck it. Why doesn't it like this? Is this not a valid? Oh, it's 1 U8 1 like this. This. There we go. We will write 1 1. This guy kind of looks like he's cheering, doesn't he? He's got like a little pom pom over here, and his like 2 arms are up in the air. You have to write a 64-bit integer to an event FD. That's A very good point. So this is 8, 3, 4, 5, 6, 7, 8. There we go. Thank you. Good eye. Good eye. Okay. Then we're also gonna have like a add FD. Oh, I need to lock the mutex. Yup. Yup. Yeah, this is all coming together, guys. It's coming together. Self, FDs, append, FD. That's going to get appended to the internal counter. Not sure if you care about the value you get from read. No, I don't think it matters. It's going to, yeah, I guess I could put man event FD. So write a call at an 8-bit integer value of the counter. If the addition would cause the counter to exceed the maximum, then the write either blocked until read is performed. Does read decrement? The value returned by read is blah, blah, blah. Semantics of read. If semaphore was not specified and the event FD has a non-zero value, then read returns 8 bytes containing the value. If semaphore was specified and the event counter has a non-zero value, then read returns an 8-byte value and the counter's value is decremented by 1. I see. Was not specified and the event FD has a non-zero value, then read returns. Oh, it just resets to 0, so it doesn't fucking matter. As long as its EFD semaphore is not specified, so every read will reset to 0, so it doesn't fucking. I guess maybe it does still make more sense though to only add 1 to avoid like overflowing and shit. I guess we could do. I think that's right, right? Little Indian. Little Indian, smallest byte comes first. Yeah, sure, fuck it. Fuck it. Fuck it. That's what we always say. So this is going to come in with a pointer to an event FD list now. And here we're just going to say event FD's signal. Boom. Which means that here we need to create an event FD list, or maybe we'll say that this is automatically initialized to this, and we have an init function that takes in an allocator and returns an event FD list, and he's just going to say return FD is equal to stood array list I32 initialized with FD with allocator. Boom. Boom, 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 boom. Okay. Bum, 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 bum. So this is a event FD list, is an event FD list initialized with an allocator. This thing needs to go to here. And it also has to go into our servers, presumably. Surely. Surely it has to go here. Which kind of means that here we need to store it. And when we, in our connection, here, we create this thing, we register it, and we just say self server event FD list add FD of self event FD. Yeah. Yeah. We need to like remove here. Remove from list on failure. And then on dnit, we also need to like close FD and remove from list. Which means that it's fine. I'll ignore that for now. Ignore it for now. Area union is ignored at 141, so here we need to do this. And then I guess also, I think that we probably want to set the event, the file descriptor in non-block mode, actually. Because we need to check if the event was triggered. I guess the file it'll get closed though anyways, and we're only going to signal it once, so it's probably not the end of the world if we just ignore it. Okay, let's try on 8. Oops, 141. This needs to be try, I guess. And this needs to be try, which means that this needs to be try. Okay, so I refresh here. Oh, hell yeah, baby! Enter was pressed, and we wake the fuck back up, and we panic in the connection. Let's fucking go! You probably want to register the event FD as edge triggered. Yeah, it is edge triggered. It's edge triggered. Everything is automatically edge triggered right now. It's kind of up to the event systems to make sure that if that they consume all of the bytes in the socket in their inner loop. Where is that? It's on like the registration somewhere. In register, we just like unconditionally edge trigger. No, don't apologize. I mean, I don't know if you would have seen. I don't know if you could have seen that detail like watching today. I don't think that's ever come up in this stream so far. So it's good you asked or brought it up. Okay, yeah, that's super sick. So I think that we got to the point now where we have this thing. We haven't really proved like the dinit path yet, but we at least have got to the point where we can. This is getting called again when we have data ready to write. And so I guess here we should just return something, like just like a page to load. So can we just like maybe, do we have our hello world page still here? We can pull it out. So we'll just index HTML. Oh, this is here. Aha. We do have it. So here we can just make our connection. So let's just say our response header is going to be an HTTP header. And his status is going to be std HTTP status okay. We're going to have, what else is in here? That's Godot open. Yeah, on the right, that is a maze that we wrote in Godot when we first started streaming to keep your guys' retention up. Because surely coding is fucking boring and nobody actually, this helps your brain stay focused. This is self-server dot, what was it? It was server index HTML len. Here we go. And our body is just the index HTML. So now we can return a HTTP writer initialized with our allocator, our header. What else is in this thing? Allocator, header, body, which is a server index HTML, and we flagged that this is not a thing that you need to free. The response body is static memory. Are you listening to music? No, but I just have my headphones in by default all the time because at the very least, like maybe there will be something playing and I want to know, and also it just like makes everything in the world quieter, which is nice for me sometimes. Okay, so now when we run this, fuck. Now when we run this, we should see that if I go here, it will not load until I press enter, and now we have hello. Oh, that's so fucking sick. It's so sick. And then I refresh again and it instant loads because enter was pressed already. So we're chilling. Oh, that's so fucking sick, man. Hell yeah. That's so cool. Okay, we need to prove the dinit path. Like just to make sure that like everything gets freed correctly. So I kind of want to there's a little trick here that you can do where there's this thing called signal FD. And this guy basically says like, wait till you get like a signal from the operating system and that will trigger like this file descriptor. So we can actually use that so that when Control C is pressed, it exits the event loop. And I have an example of that already over here somewhere. Here. So I can just copy paste this. Fuck it. I don't really care about like the fact that we're copy pasting like mad because this is prototype code. So this guy just creates like, he says like, hey, I'm gonna like disable SIGINT. So like, don't run the normal signal handler. And instead I'm going to attach that to this file descriptor. Then we just register this thing with the system and we're chilling. So we just say like, signal handler is equal to signal handler init. And then we just register with the event loop. Signal handler FD. Signal handler. And this handler, just by like in the thing we copy paste from, just requests that the server is shut down when it's triggered. So we're chilling. Like this should just mean that when I run this now, if I press Control C, we should get like a graceful exit. Now there's no proof here that there's a graceful exit, but we can prove it pretty easily by just doing like at the top here, defer, std, debug, print Bye-bye. Right? And so if I don't register this thing, if I don't register this thing, and I hit Control C here, nothing happens. We don't see that bye-bye. But if I do register it, we should see that defer block run. Fuck! Maybe I did something wrong here? Yeah, there's something wrong. Something wrong. This is supposed to work. So why the fuck is it not? Let me check what we do in the other version of this. Do we... Did I, like, manually disable the signal handler outside of this thing before? No. I thought that this was it. Maybe I made a mistake. I don't see anything in your code that uses signal sig action in parallel to it. I thought that this was supposed to do it, but maybe that's not true. Because when I did like man signal FD, I just kind of followed their example here, where this is supposed to block the thing, I thought. That's what I thought. So here they add sig and sig quit. Signal FD, -1, mask 0. Maybe I just fucked up when I added this on the main loop. Maybe we'll do this. Let me try writing this here instead of doing a defer block, just in case like that defer block ends up with like standard output being like deinitialized in some way. No, it's clearly not working. Let's make sure it's stood debug print running event loop. Yeah, so it's just not fucking doing it. Why? I thought I tested this before. Yeah, very strange. So stood debug print callback. Let's see if we at least get here. We probably don't, but let's check. Nope. Yep, that makes sense. So it must just be that you're right that I need to call something to like disable, like mask the thing off. So how do I do that? Man signal sig action? How do I just like block something? Linux block signal. It means that the signal won't be delivered now, so you can send the signal. It won't be delivered as soon as the signal is unblocked. Yeah, I could have sworn that this is it. I wonder if it's because I'm running it through Zig run. That could be it. That definitely could be related. But it's not. Dude, I'm fucking losing my mind. What is like, okay. Oh. Zig. Let's just double check that. Sorry. Yeah, I'm fucking... Okay, man sig proc mask. What does this do? Examines and changes blocked signals. Refer to pthread sigma. Okay, that's weird. Man pthread sig mask. Function is just like sig with the difference that it uses multi... See sig proc mask. Oh, you just did! That's where I just... Oh, man 2. Man 2. Okay, so standard C library, blah, 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 is used to fetch and or change the signal mask of the calling thread. The signal mask is a set of signals whose delivery is currently blocked for the caller. See also signal. Behavior of the call, so if we block it, it's blocked. Why is it... Fuck, man. So if I don't call register here, like, if everything is working the way I would expect this to do nothing then, which is clearly not the case. But here I would expect that the signal is blocked, and so I hit Control C and nothing happens, but it clearly is not the case. Sig proc mask not blocking sig in. Yeah, like, am I fucking high? Is it because I've spawned a thread and that thread is like related, like causing the interrupt to get hit in like another thread or something? Sig empty set. This is like exactly what I've done, right? Am I fucking crazy? Here I called sig empty set. I added sigint. Yeah. And then I called sig proc max block. Yeah. Let's just double check here if we call this code here and then don't attach it to signal FD at all. Yeah, I just don't get it. That's very strange. Let's try not spawning this thread. Ah, there we are. Okay. So this thread spawn is actually fucking with it, which is pretty interesting. Good eye on whoever just suggested do it without the thread spawn. I think that you're probably right. There's probably something to it where I need to do the initialization of the thing like right up front so that spawned threads inherit the blocked signal or something like that. That would make sense. It's good to know that I'm not fucking nuts. That makes me feel really good. Like, that means that this was working at some point and just not in the context of multi-threaded code. There we go. We found it. So it says bye-bye now. And so now what I want to do is I want to run Valgrind on this thing. Not being fucking nuts is good indeed. Yeah, exactly. So let's zig build exe and Valgrind leak check full, which shouldn't really matter because we're not using calculator. But what I'm more interested in is track FDs on HTTP test. Expected positional argument. Oh, right. So source HTTP test. And now what I'm hoping here is, so these are normal is valid memory checks trigger a problem here in Valgrind, but that's fine. This is the wrong. Oh, so here we were deferring, and I want to spawn a second. I actually want to do this twice at once. So here we're seeing two threads that are blocked on me pressing enter. I press enter. Both of these guys resolve. Very good. And I hit Control C. We see bye-bye. And we see, what did we fuck up? So here we leaked some memory when we appended a file descriptor to our list of FDs. So that's our event list. We didn't fully clear out. So here we need to defer event list FD dinit, which means that this guy needs to have a function dinit. Which I guess needs to take in an allocator because we didn't. No, we're chilling. We just did dinit self is a event FD list. Self FD's dinit. Boom. What else did we fuck up? Our event FD was not closed correctly, so our connections, these guys need to say if self event FD self or stood POSIX close FD. And who else is mad? Syscall to event FD. So it's just the two open file descriptors. And then we have those like open file descriptors to Git or open sockets to GitHub from the Nix shell environment, but everything else seems chill. Everything else seems chill. Okay. Oh fuck, I pressed enter. Fuck, I can't press enter. No pressing enter allowed. So here we refresh. Both of these guys are blocked. I press enter. Both of them get resolved. I Control C. We see bye-bye, which means that we're exiting cleanly. We have no errors saying that we have left file descriptors open, left unused memory. Everybody's happy. That's fucking sick. Let's fucking go. So if syntax gives you a alias value for not null value or something, yeah, exactly. Yeah, that's pretty sick. So I think that kind of like proves out the concept. So we have now the ability for an arbitrary connection to wait on some arbitrary condition. And now all that we have to do is like, in terms of like authentication flow, we just need to like kind of do something very similar to this, except like block the event on something else. Like something that's like less silly than just pressing enter. Okay, so what did we do? What did we do? Because I feel like I went through all of this stuff and I just kind of kept going like piece by piece. What's next? What's next? What's next? And I actually don't have like a good mental model of like the full picture. So it'd be kind of interesting to try to draw that out just to make sure that I understand it. So we have like our TCP. Okay. What's the best way to draw this? Event loop. Right? He's got like a bunch of file descriptors. One of these file descriptors is like TCP listener, who I guess is kind of tied to main stack memory of TCP server. So when this is called, it triggers this. When this is triggered, he creates HTTP connections. So every time this is called, I guess it creates like two objects. One is like an HTTP connection. And then the thing that we added today was this connection data. And then like kind of through some like inheritance stuff, the HTTP connection gets like a handle to this. Then the HTTP connection, when he gets kind of like registered here as like a, TCP socket. And so this is kind of connected like this. Now, what happened, what we added was that TCP data comes in, and so the HTTP connection calls like read on the TCP socket over and over again until he finds a full HTTP request. Then what did we do? We kind of like call into this connection data thing, and we say like, are you ready to write? And he says like, no, I am not ready. And so then what he does is he creates like a new event file descriptor that also is connected to this same HTTP connection. Yeah. This event file descriptor also gets passed over to a like input tracker. We'll call it input thread. And so then what happens is we get some input, we trigger this file descriptor, this pulls the HTTP connection again, then he calls in here again, he says, yes, smiley face, we are ready. And then he calls back and he continues on with like a write call. It's a little complex, but it's not that bad. And then later, what happens, we added some like reference counting here as well, ref count. And so what happens is like this gets closed, he still stays alive, this gets closed, then he dies. And when he dies, he frees this as well. Not bad. A little complex, to be honest. But I don't know if like the only way to like reduce the complexity, I think, is to kind of like ungenericize this like HTTP connection, which I don't want to do. So it kind of is what it is. And it's not that, it's manageable. Is your program polling for FDs that are ready to go once epoll fills them out somehow? So epoll is the mechanism for Linux to tell us when file descriptors are ready to do something. So like this HTTP connection structure here, he kind of like, when we call into him, he like consumes as much data as possible. He's like, yum, I'm going to slurp up everything I can. And so if he does that correctly, the TCP socket will like get like drained of data. And so the event loop will then say like, okay, so the state has changed from like data exists to data does not exist. And when data exists again, I'll call you again. And then we just make sure that every time we call in here, we consume as much as we can. Oh yeah, okay. Not that bad. We also looked at like signal FDs here as well, which is kind of fun as well. Okay, I think that my brain is like melting enough that we call it here for the day. I know we're only at like an hour 40, but I don't really think that I'm going to be able to like apply this onto something useful right now. I think probably what's going to happen is we'll come back tomorrow and we'll try to go back to that authentication flow, right? So we want to be able to do this flow where we send out a connection, like a client comes in and talks to us. They go give us a code from Twitch and we talk to Twitch and block their connection until we are ready to go. So what we'll probably do is we'll make like a thread that's like getter thread. And we'll kind of follow the same pattern. He's going to have the event FD and he'll stall this response to the client until he manages to get a response from Twitch and it'll signal on the event file descriptor. Pretty cool. Pretty cool. I'm happy with that. Thanks for watching, guys. If you like what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. Right now, we're kind of working on this long-term project. I don't have it open anymore, but maybe I can get it open real quick, of the ball machine. So, you know, this Rube Goldberg machine where simulation state is kind of like handled by WebAssembly chambers. So we're working towards users being able to upload environments that these balls will roll around in that will be kind of interesting. And so that's kind of where I'm working on login stuff right now. So if you want to check that out, we'll be back and working on this tomorrow. Even if the project itself is not necessarily the most like invigorating project, I think that it's allowing us to explore a lot of useful concepts, right? We've looked at like async HTTP with ePOL. We've looked at WebAssembly on a server and in the client. We've been looking at, there was something else in here that I thought physics systems is kind of fun as well. So even, you know, there's lots going on if you want to check it out. Then there is a GitHub link in the Twitch description as well, where code for all this stuff will eventually end up. This ball machine stuff, I think, is a little bit out of date, but it'll hopefully get updated soon. If you're watching on YouTube, there should be a Twitch link in the YouTube description if you want to swing by and say hi. Like, subscribe, Twitch Prime, and let's say goodbye to YouTube and Twitch. Let's figure out who to raid.